Hello, I'm Mr. McBrien. This is SPH3U, Smugglers Cove. So we've seen the first of our more complicated projectile problems. We're going to look at another one today. As we've discussed, it's common to have cases where the launch and landing heights are different for our projectiles. We saw how to calculate the hang time for this asymmetric case yesterday. Today we're going to see how to get the impact velocity. So we're going to discuss this other delta dy not equal to 0 problem. What's the impact velocity of a cannonball? We're going to review how to extract the components of projectile motion, calculate final velocity for this asymmetric case, and review recombining components to get the impact velocity. So yesterday we found the hang time for our asymmetrical case. So what about the impact velocity? Some examples of this kind of thing. How hard will the pitch hit the catcher's mitt? What's the speed of the juggling ball when it hits the floor? What's the velocity of an arrow shot at 45 degrees above the horizontal from the top of a wall? All of these are examples of asymmetric cases. So here's the one we're going to do today. The Imperial Navy are in Smugglers Cove and want to hit the pirate stronghold 114 meters above the sea. They need to fire their cannonball at 65 degrees above the horizontal to hit the target. The velocity of their cannonball coming out of the cannon is 92 meters per second. And what we want to know is what's the magnitude of the impact velocity. Will it be enough to knock over the wall of the stronghold? Okay, so we can start out by laying out what we know. We know that our overall velocity is 92 meters per second. Our angle is 65 degrees. The height at which we have impact is 114 meters. And of course, our acceleration due to gravity of negative 9.8 meters per second squared. And what we want to know is what's V2. So to start with, we're going to extract our vertical component from our motion. So you'll recall that from SOHCAHTOA, we get sine 65 degrees equals y over 92 meters per second. Rearranging, y equals 92 meters per second times sine 65, or 83.4 meters per second. So again, this is our vertical component of our motion. How fast the cannonball is going up at point of release. Now using that, we could, if we wanted to, calculate hang time, but in this case we're not looking for time. We're looking for the velocity with which it'll reach the point 114 meters up. So we can use V2y squared equals V1y squared plus 2a delta d as an expression. We have our V1, our acceleration, and our distance traveled. From there, it's a fairly trivial problem to substitute in and get our velocity from the expression. Now notice the plus minus term here. We get two solutions that fit the problem, right? We can get positive 68.7 meters per second or negative 68.7 meters per second. And both of these solutions are real. We just have to ask ourselves, was the impact when the cannonball was going up, i.e. positive 68.7 meters per second, or was it when it was going down? And of course, from our diagram, we saw that it was going up. And so our answer is that the vertical velocity is 68.7 meters per second. But is this our impact velocity? Part B, why not? Well, we found the y component of the velocity, but we don't know overall magnitude or the angle, so we don't have the So how do we get that? Well, we have the vertical component, we need the horizontal component. And of course, the horizontal component is constant across the experiment. So all we have to do is go back to trig and take cos 65 times our initial velocity. Remember, it's the initial velocity. And we get the horizontal component of our velocity, 39.9 meters per second. Now we have everything that we need in order to put it all together and get our overall velocity. We have Vx equals 39.9 meters per second. Remember that Vx is constant across the whole experiment. Vy equals 68.7 meters per second. And our overall velocity is just the sum of this. And we've done this before. Pythagorean theorem gives us the magnitude of 79 meters per second, and tan theta gives us the angle. So we get 63 degrees above the horizontal for our angle. And if we want to go back and look at our situation, these results are reasonable, right? Our velocity is lower because it's been moving upward and slowing down, and our angle is dropping as our y component is disappearing, but our x component is remaining constant. So these results do seem reasonable. And our impact velocity is 79 meters per second, 63 degrees above the horizontal. Okay, so hopefully that gives you a good idea of how to get an impact velocity for a projectile. For your homework, please have a look at a couple more Smuggler's Cove problems. What would the impact velocity have been for our cannonball if we had hit the stronghold on the way down instead of up? So here's the diagram here. How does this velocity, impact velocity, compare if we hit it on the way up at the same height? Please have a look at these. This should help you to better understand projectile motion. And the other question is, what would the impact velocity be if the cannon's muzzle velocity were 58 meters per second and we had needed an angle of 71 degrees above horizontal to hit the target? Thanks, and have a great night.